let's take a look here, Bruninha. This week, we planned to start Unit 10, okay, and do pages 74 and 75 today, and on Thursday, page 76, all right? So we are almost finishing the book, so we just have a few more lessons to go. So today we are going to talk about technology. I love this topic. So just to share you the book, just a second, this is another book. Let me go to our book. It's because you were taking some time to arrive, so okay,
Yes.
Maria, good. So this lesson has as a title, All Things High Tech. So it's technology, right? And we will see something about microprocessors. But before that, let's take a look at some important points that this lesson will bring us, all right? So we will start by checking out a few details here. First of all, in activity one, they want us to underline the nouns in these sentences. So I've already highlighted them for you, okay? So the
Mm-hmm.
nouns in these sentences are brother, computer, world, and laptop, okay? They are the nouns.
Mm-hmm.
Now, okay? Now find a definite article. So here in purple, we found a definite article, the, okay? Now
Mm-hmm.
find an indefinite article. So here in pink, an, okay? So that
Uh-huh.
is an indefinite article. Find a possessive adjective. So in green, I highlighted the possessive adjective in the sentence, my, okay? So possessive adjectives, they come before nouns, okay? And finally, find a possessive pronoun. So here in blue, there is an example, okay? Mine is just an old laptop. So here, mine is a possessive pronoun. What is the difference? A possessive pronoun I use when I substitute a noun. So here, look, they are
Mm-hmm.
talking about computers. So mine is equivalent to my computer. So I'm
Uh-huh.
substituting that by using only the possessive pronoun. Okay. All right. Now in number two, we have underline the reflexive pronouns in these sentences. So there are two examples here, himself and myself, okay? We call them reflexive pronouns. So let's see the sentences. Mike programs his computer himself. So he does it all by himself. He doesn't need the help of a technician. Maybe if he has a question or two, but he programs himself. I live by
Mm-hmm.
myself, which suits me fine. So if you live alone, you can say that you live by yourself. For example, I don't live by myself. I live with my mother, my sister, okay? So
Mm-hmm.
I don't live by myself. So they are reflexive pronouns. Why are we looking at all these parts of speech? Why? Because the topic of Unit 10 is about noun phrases. So what are noun phrases? Noun phrases, Bruna, are phrases that have a noun, of course, and other words that exist around the noun. So it makes a phrase. For example, in the world. This is a noun phrase because I have a noun. Okay, the best computer. It's a noun phrase because I have a noun and I have the words qualifying that noun. An old laptop. This is another noun phrase. My brother. It's a noun phrase. Okay. So noun phrases must have a noun, and the words around the noun, they help create the noun phrase. So they can be articles, possessives, possessive pronouns, possessive adjectives. They can be indefinite articles like this one here. Okay. So let's take a look at some more examples. And to help us, they're going to show us a text about something quite interesting. So here they say, read the text about microprocessors and answer the questions. Okay, so let's see the questions first. Do you agree with these statements? Why or why not? Let's take a look at the statements. Microchips are huge. Microchips are tiny. So, do you agree with them? Oh, by the way, huge is the same as very big. Okay? So, do you agree with the first one?
No.
No, why not?
No.
Mhm.
Because it's small.
They are very
No.
small, yeah.
Uh,
Physically speaking, they are tiny. They are really small. So tiny is
mhm.
very small. Huge can be the capacity. They are small, but they have a huge capacity to
Yes.
store information and also to perform tasks. So they are super small, they are tiny, but in other words, they can also be considered huge because of the things they can do. All right.
Mhm.
So, what
Yes.
things, yes, it's interesting, isn't it? What things in our daily lives have microchips in them?
Mm, my cell phone.
Yes, of course. Yes. Uh-huh. What else?
Mm, my TV.
Uh-huh. Sure. Now we have smart TVs. So they have microchips.
Mm-hmm.
Sure. Our computers, laptops, right?
Yes.
So in what ways are computers very simple?
Não entendi a pergunta.
Okay. In what ways are computers very simple? What ways can we consider a computer something simple?
Hum, não sei, não entendi o que
Uh-huh.
quer dizer.
Okay. In what way means de que forma ou de que formas, okay?
Hum,
So in what ways are
uhum.
computers very simple? We
Sim,
don't
mas
know.
como assim? Tipo, eu não tô sabendo entender o sentido da frase.
Uh-huh. So when I say in what way, I'm asking de que forma, ok? So de que forma os
Uhum.
computadores são muito simples? That's the question, okay? In what ways are computers very simple? If there are any ways they are simple,
Hum,
what do you think?
não sei.
Uh-huh. We don't
Não
know, right?
sei.
Because computers are usually very complicated. They are complex, right? So In what ways can they be simple? I don't know. Let's see.
No,
Okay.
I don't know.
Yes. So number 4, how long does it take to make a microprocessor? We are going to see here, okay, in the text. How long,
Mm,
okay, does it take to make a microprocessor? What do you think? Let's make some guesses.
I think it's very long,
Very
very
long.
long time.
Okay. All right. Why do designers put pictures on the ships? Did you know that? Yeah, they do. You know those very tiny ships, really tiny, tiny ships? They manage to put pictures there. Yeah, they print,
Mm,
they print some images and they put these images on the ship. How can they do that?
nada, nem sabia que era
Yeah,
assim.
it's true. They can do it. Yeah. Now, question number 6. In what ways is the future exciting? The same question here. In what ways? Okay, Bruna? De que
Uhum.
formas? So, in what ways is the future exciting? When we talk about technology, right? Anything is possible.
I think yes.
Mhm. But in what ways? So here they want examples. They want to know, for example, what will happen in the future that will make it exciting. Okay, so like I
Carros
said,
voadores.
yeah, maybe. I don't even think about flying cars, but um, better or more intelligent computers, maybe even robots. I guess in the future, there will be a lot of robots around, okay?
Uhum.
And robots that are like human beings, just like you and me. They will talk, they will perform tasks, and they're
Uhum.
improving. Every day they are improving artificial intelligence, as they call it. AI. So I think AI
Uhum.
will become a reality in the future. That's why I think um, it is going to be exciting. Okay. So, of course, to answer
Uhum.
these questions, we should read the text. All right? To answer these questions, the best thing to do is to read the text. But before we read the text, I will try to show you the short video about microprocessors and how they are made. Okay, Bruna, let's see. It's really interesting.
Uhum.
So let me share that with you. So the name of the video is From Sand to Silicon, the making of a ship by Intel, right? This is from a special manufacturer, but just for an example, okay? incredible, isn't it, Bruna?
Yes.
How can they make something so complex only with a tiny piece of material, right? Like very small and put so much information there. Wow, this is
Mm-hmm.
really amazing. It's really shocking, right? So let's take a look now at our text to see how they can make this, right? They will explain here. So look, the biggest thing since the invention of the wheel. So let's take a look at this reading part. Here we have the subtitles, right? So actually this the subdivisions here to help us as we go, right? So first of all, microprocessors, what are they? So let's see. A microprocessor, also known as a microchip or just a chip, is a small, thin piece of silicon that has been printed with transistors. Okay? One chip can contain hundreds of millions of transistors performing billions, yes, billions of calculations each second. The smallest are just a few square millimeters. So you see, they are very small. The
Mm-hmm.
microchip is the most complex product that has ever been made. So, what exactly are microchips or microprocessors? So, they can also be called a microchip, right? This is another
Mm-hmm.
name for processor, and they are very small, thin piece of silicon printed with transistors. Okay, these are these little circuits here. Okay? So imagine one chip can contain hundreds of millions of transistors. Wow. This is shocking, isn't it? Wow.
Mm-hmm.
And that's why I totally agree. The microchip can be or is the most complex product that has ever been made. I could never create a microchip. Could you? Could you create something like this?
No.
Yeah, me neither. This is so complex, so complicated. Now, what do they do, Bruna? Let's see. Microprocessors are the brains of your personal computer. So, do you understand the meaning of brains?
No.
Brains is the same as cerebros, okay? So, they are the
Mm-hmm.
brains of your personal computer. They control
Mm-hmm.
everything in our lives. They are used in all digital devices, cell phones, calculators, cameras, radios, ovens, refrigerators, washing machines, and watches. Without microprocessors, modern cars wouldn't start or stop. They are about, there are about 60 per car. So in a car, there are about 60 microprocessors. TV
Mm-hmm.
remotes wouldn't change channels, and we couldn't text each other on our cells. Doctors and surgeons wouldn't be able to diagnose, treat, or operate. Nearly all of their equipment contains microchips. So it's everywhere.
Mm-hmm.
How can something that is so common, how can something be so difficult, so complex, right?
Yes.
Wow. Imagine. And who produces them? Who makes them, right? So first, how do they work? Transistors are microscopic electronic switches. Do you know what electronic switches are?
Switches is. Esqueci. Relógio.
No, a switch is something that turns on and off, something that you use to turn
Ah,
something else on and off. So switch is like chave, okay?
sim.
But electronic,
Uhum.
okay? So
Ah,
transistors are
yes.
microscopic electronic switches that turn on and off billions of times a second. Wow. It's hard to
Hum,
believe. Yeah, it's hard to believe that basically that is all a computer does. It either says yes or no. So here, look, basically, uh, this kind of equipment is only produced to answer yes or no. Did you know that?
hum,
All computers do that. They simply say yes or no.
caramba.
Yeah, you see, we can do so many things with our computers, but the root of the computer is manufactured to just say yes or no, but they do it
Uhum,
billions of times in a second.
uhum,
That's what makes them so special. Okay, the process to process the words, images, and sounds we use every day, computers and other devices transform these communications into a simple code that uses the numerals 0 and 1 to represent the on and off states of a transistor. Okay, so in the computer, they, of course, these little things here, they understand numerals 0 and 1. And by alternating them, they decide
hum,
if it's on or off. So let's consider that 1 is on and 0 is off. Okay, so they go,
uhum,
all right, this is what they do. This language of zeros and ones is known as digital information. Okay, so this is what we call digital information because it's reduced, uh,
uhum.
reduced in zeros and ones, basically that. So maybe that's how we should answer that question. In what ways are computers simple? In this way.
Uhum.
In this way, because they basically decide
Ah, entendi.
between 0 and 1. They simply say yes or no. Okay.
É,
Now,
aham.
how are they made? It takes, look at this, Bruna. It takes less than a month to make a microprocessor. Less than a
Hum,
month. Incredible. And it involves
caramba.
over 250 manufacturing steps. So there are lots of steps to follow. Okay,
Uhum,
so, but it can take years to design one. So you can make a microprocessor in less than a month, but you need to design one. To design, it can take years, okay? Sometimes the engineers put pictures on the surface of the ship because they want to show it's theirs. So here, for example, we have a microchip and the scientists, the engineers, they sometimes print an image here that we cannot see in human eye. With the human eye we cannot see. We need to use a microscope so we can see the image. That image is a kind of personalization. They personalize the ship. So if we see that image, we know who made it. Okay?
Mhm.
The pictures are incredibly tiny and can only be seen with a microscope. Just like I said, they are like the designer's signature. Okay?
Mhm.
So it's a way to do it. I will try to find a picture that I saw the other day where they show an engineer putting a picture on a microchip. I'll try to find this video. Now,
Ok.
what about the future? The digital world is only a few decades old. So it's something very new, okay? There are still countless more things we can do or we could do with microprocessors. Soon, they will even be able to make themselves. Wow. No one knows what will happen. Only time will tell.
Caramba.
Yeah, so you see here, this is a very nice prediction. Soon they will even be able to make themselves. So one microprocessor creating another one. So I guess now
Mhm.
this is pretty much true because there are
Mhm.
computers that can create other machines, and so this is
É.
possible, right? So that's
Uhum.
why I guess when they asked about the future here, there is a question about the future. In what ways is the future exciting? So here we can see that,
Mhm.
right?
Yes.
That probably the microprocessors we have today will be able to make themselves, and nobody knows what will happen, right? So that's exciting.
Uhum.
Okay, let me just highlight that. This is very important to answer. So let's try to answer the questions, Bruna. Now we highlighted some important pieces of information. And then here we have number 2. What things in your daily lives have microchips in them? We've already answered. Question number 3. In what ways are computers very simple? Or in what way are computers very simple? We have the answers right there.
Uhum.
Look, basically,
Yes.
all a computer does is either say yes or no. This is the answer.
Uhum.
Okay, you can put it there.
Uhum.
Basically, all the computer does is either say yes or no. Next one, how long does it take to make microprocessors? Look,
It's like less than a month.
good,
Month.
less than a month. All right, so it's very good because it's in such a short period. You can make a microprocessor in less than a month. My goodness.
Uhum.
So, in what ways is the future exciting? Here we have the answer. Okay, so
Deixa eu
exactly,
ver.
yeah, soon They will even be able to make themselves. They who? The
Uhum.
microprocessors. So soon, the
Uhum.
microprocessors will even be able to make themselves, and no one knows what will happen. So that's why
É.
the future is really exciting. Let me try to see if I find the video where a scientist is printing an image on a microchip. Let me try to find it.
É.
Just a moment.
This means that elements in the 13th or 15th group have to be used in this process, referred to as doping. Boron and phosphorus atoms are the most suitable elements in these groups. They are very close to silicon on the periodic table and therefore have very similar properties. Phosphorus has 5 outer electrons. When it is inserted into the silicon crystal lattice, the 5th phosphorus electron can move freely. This means that the silicon phosphorus crystal is N-conductive. In contrast, boron atoms only have 3 outer electrons. When they are introduced into the silicon lattice, one silicon electron has nothing to bond to. This creates electron holes. The holes move through the crystal like positively charged particles, making the material p-conductive. Transistors are built on the p and n conductive layers that exist in a doped wafer. Transistors are the smallest control units in microchips. Their job is to control electric voltages and currents, and they are by far the most important components of electronic circuits. Every transistor on a chip contains p and n conductive layers made of silicon crystals. They also have an additional layer of silicon oxide, which acts as an insulator. A layer of electrically conductive polysilicon is applied on top of this. Every transistor has 3 terminals. The middle one is attached to the gate, which is the electrically conductive polysilicon. If an electrical charge is applied to only the 2 outer terminals, electricity cannot flow as the transistor is blocked. This changes, however, if an additional charge is applied to the middle terminal. Electrons from the p layer are then pulled toward the middle terminal and accumulate at the area bordering the silicon crystal and the insulating gate oxide. A channel then forms underneath the gate between the islands of N-conductive material. Electrons can now flow through this channel. The electrical circuit is closed. In this way, the transistor can be switched back and forth between current enable and disable, between 0 and 1, on and off. But how are these layers created on a wafer? The process to manufacture chips from a wafer starts with the layout and design phase. Highly complex chips are made up of billions of integrated and connected transistors, enabling sophisticated circuits such as microcontrollers and crypto chips to be built on a semiconductor surface measuring just a few square millimeters in size. The sheer number of components calls for an in-depth design process. This entails defining the chip's functions, simulating its technical and physical properties, testing its functionality, and working out the individual transistor connections.
Bruna, you see how complex it is? Wow,
Yes,
it's more
very
complex.
nice.
Yeah, and it's really complex. It's very difficult. I would like
Mm-hmm.
to know a person who works with this. Do you know anybody who works with this, who creates um, these microprocessors or
No.
microchip? Neither do I. It's really amazing, isn't it? So I will make sure I post this video on our page here on Google Classroom
Mm-hmm.
so we can watch the whole thing, right? Because it's a little long,
Mm-hmm.
but it's also very interesting. Okay?
Yes.
So to begin, I think that was enough for us. It's already almost 6:30, and I would like you to do some exercise about the noun phrases. So let me show you the homework I posted here. Yes, there you go. The workbook pages are 64, 65, and 66. They are all about noun phrases. But there is also some interesting information here I posted on the topic if you don't have the material.
Mm-hmm.
So you can check this. It's also interesting about the dark web,
Mm-hmm.
and try to do one or two of these worksheets about articles and possessives. They are very interesting to begin. Okay, Bruninha?
Okay. Mm-hmm.
So really, thank you so much for coming, and I hope you enjoyed because this is very interesting.
Ah, eu gostei.
It's really interesting. So, Bruninha, see
Uhum.
you on Thursday, okay? Don't miss our class on Thursday
Ok.
because we will expand a little bit more the topic of noun phrases and we will see more
Ok.
technology, okay? Bye bye,
Uhum.
Bruninha. Take care.
Bye.
See you.